All right, this is number 2 in practice 1 for series. All right, so read the problem first. A 30-volt battery is connected to 3 identical light bulbs in series. Each light bulb has a resistance of 5 ohms. Okay, so the first thing you want to pick out is that it's a series circuit. All of these are in this practice, but okay. All right, and let's go ahead and draw the schematic. Okay, so we're going to have our battery, and then we're going to put a couple circles. Okay, so we can track the voltage. Then I'm going to see that light bulb resistor up here, okay, with an ammeter. Okay, I'm going to have, whoops, oh, nice. I'm going to have another resistor here. Another resistor here. Okay, we throw another ammeter down here. And then another one here. Okay, all right, so you can kind of see what you need to do for how many circles. Again, you don't need as many circles as shows in the picture. You just need to make sure that you have enough to track where there's a change. Okay, and as you practice, you'll get better at it. Okay, all right, so it says I have a 30-volt battery, so I know that that's going to be the total. Okay, and each light bulb has a resistance of 5 ohms. So we're going to say R1, R2, and R3. And oops, I kind of forgot to label this on the last one. We should probably have been doing this. R1, R2, R3. Okay, all right. So my battery, remember, it's always going to be 0 volts at the negative side of the battery. And this one's going to be 30 volts at the top of the battery. Okay. All right. Key then is to keep transferring those voltages around. So this 0 volts here, I'm going to follow this all the way until I see another resistor. So I know that one's going to be 0. Same thing on the top. This is going to be 30. Okay. All right, now notice, I don't know any current. I don't know anything else. I don't know any voltage drops. Okay, so now the puzzle starts. You have to try to figure out what do you know. All right. So once you've exhausted all of the given kind of information, then you want to use the principles of a series circuit. Okay, and I seem to know a lot of the resistances, right? So I want to remember in a series circuit, I'm just adding those together to get to the total. Okay, so this is going to be 15 ohms. All right, 5 plus 5 plus 5 is going to be 15 ohms. Okay, all right, now V equals I times R. Okay, now in this top row, I can see that I have 2 of the 3. Okay, so now I can go ahead and solve it. So if I have V equals IR, okay, and again, you don't have to show all this work every time because obviously we can see this is probably going to be 2, right? But it's just for the sake of it, let's do it. Okay, so 30 volts over 15 ohms is going to be 2 amps. Okay, so you need to make sure that you have the right unit in there. Remember, current is measured in amperes or amps. All right. Okay, so now I have to see what else I can know. So now I know everything about the total. Okay, and in a series circuit, I know that the ammeter is going to read the same everywhere because there's only one path. Okay, which means that all of these currents are going to be 2 because it's a series circuit. Okay, I is the same. Okay, all right. Now I can simply go through and work this out because I know V is going to equal I times R. So I'm just basically multiplying these. So I'm going to have, let me do this another color. No, not purple. I already used purple. Okay, 10 volts, 10 volts, 10 volts. Okay, right? Because just like in the lab, most of you did, if each light bulb has a resistance that's the same, they're all going to get the same voltage drop. Okay. All right, so now I want to go back and finish my diagram, right? So I know that there's going to be a 10-volt drop across each of these resistors, okay? So if this voltage in front of this resistor is 30 and it drops by 10, then I know that this is going to be 20, okay? Carry that around because there's no resistor, so that's still going to be 20. Okay, there's going to be another 10-volt drop here, which is going to put this to 10. Okay, and then there's going to be another 10-volt drop here, which better put this to 0 because it has to always end at 0. So if it doesn't, that means you messed something up. Okay, that's going to be 0, so that's how it's going to look. All right. Okay, then we're going to go ahead and make the voltage graph. So remember, you're going to have A and B around the battery. Okay, and then letters C, D, E, F, and G, H around the resistors. All right, so it's going to be A, B, C, D, E, F, G, H. and I'll just do 10, 20, 30 volts. Okay, and then I just have to graph it out. All right, so at A, it's 0, and at B, it's going to be a plus 30. Okay. Over here at C, I can see it's still 30, right? Because there hasn't been any drop. Okay. And then at D, it's dropped to 20. That's my first resistor drop. Okay. Carrying that around, right? Another wire. So it's going to look flat again because there's not going to be any drop. It's going to drop another 10 at the next resistor. Okay, then by the time I get to F, I see it's 10. At G, it's still 10 because there's no resistor here to take a drop. And then my last resistor is going to drop down to here. Oops, and I was supposed to do this. I don't think I did that on the last video. Shoot, sorry. Okay, back to A. Should have done that. All right, good. Okay, so that's number 2. So hopefully now you can do some of these on your own. I will warn you, though, these first 2 examples had resistors that were all equal, okay? The rest of them do not, all right? So really make sure you do number 3, try number 3, see what happens, and then you might want to check it and look at the video to make sure that you can do that one when the resistors are unequal, okay? Oops, how do I turn this off?